Okay, now in looking at this question, we're given a molecular formula and asked to make some deductions about it based on what it does. The fact that it's optically active means that when we draw the structure we have to consider the fact that we're going to have 4 different groups attached to a carbon, and when we do compound B here, that also has to be the case. Now when looking at C6H12O2, the fact that it reacts with NaOH suggests that this could be a ester, because esters have 2 oxygens in there, and also they can undergo acid or base hydrolysis. And also, if we look at this, we could consider the fact that this could be a carboxylic acid, because a carboxylic acid would undergo a reaction with a base and sodium hydroxide. So we need to sort out first of all, if we can, is C6H12O2 an ester, or is it a carboxylic acid? It's more than likely it's going to be an ester. That's going to produce 2 different products, and but now the clue here really is in the fact that after we react it, we, well not we, but whoever's doing this acidifies it, and which would in effect end up with the same initial starting reactant. So we'd just be turning it back to a carboxylic acid. We'd be protonating that, well, we'd have a C double bond O, O minus, we'd just be protonating that again. So, and the inference from this, or the suggestion, is that we're going to have a different product, and that really does mean that it has to be an ester that we're starting with. Now, if we were to look at a standard simple ester like this, when I say simple I mean just a straight linear chain, and the thing you've always got to consider that, you know, many organic chemicals will have branches coming off them, so don't be blind to that. Is what if we, for instance, were to consider this is the chiral carbon, we immediately have 2 H's of the same. It would be the same for this whole chain going back here. Obviously anything with a double bond can't be it, so this cannot be one of the structures to start with, nor can be anything where we shift this back and forth, as you know, we shift back, you know, where we have the you know, the alcohol or the acid side of the ester. No matter what, we're going to end up with something which is not optically active, so we do need to have a branch coming off this based on the optical activity. Okay, now what I've done is I've redrawn a possibility, and in looking at this, we've got a methyl group is all I've drawn off. There's 1, 2, 3, 4, 5. Just make sure I've got 6 carbons there. And H, yes, that's correct. So when we look at that, obviously we've got, these are the 4 different groups here. Now obviously I can't have a methyl group coming off here as well, because that would just be the same. If I extended this out here, that would be to make it CH2, CH3, that would effectively be the same molecule, because we have free rotation around that carbon. And so we really can only have one methyl group coming off here. And if we shift this methyl group to here, well, that means we have 2 methyl groups coming off this carbon. So there really is only one place for that, and that's with this being the chiral carbon. Okay, so that's one possible structure. Now all we've got to do is try and see if we can move that around somewhat and have different structures. Now, having identified one of the products in A, you should kind of realize that the ones in B are just going to be, if this is from A, then B must be a product of this one. Okay, we've still got another 4 to do, but we may as well get started on the B one. So that's an A, and then there's a B. So if we react this and it's then acidified, it undergoes base hydrolysis, then it's acidified. Now for a start, this group here, which will become a methanol, is going to be water soluble, so we don't have to include it. So on the other side, all we're going to be doing is drawing the acid, and that's going to have a OH. So it's going to basically just be this molecule redrawn on the other side for B. Now, and with this having been removed and not appearing as a product in B because it is polar and it would not appear in the organic layer, so I won't go to the trouble of redrawing that. Again, that's all it would be. Okay, now we've just got to see if we can, and there is a little bit of trial and error in this, and trying to look at the structure and then see if we can change it by removing the ester link into different positions. And for instance, if we were to move the CH3 group along, that's going to mean there's a CH3 group there, so that's not going to, so we can't just move the methyl group there. So there's not much we can do on this side at the moment. Now all I've done is redraw it, putting the ester with the alcohol side here, with just having one on the acid side there. And if we look at this, if these were all just H's, obviously this couldn't be an optical isomer. Obviously I don't have all of the 1, 2, 3, 4. In fact, if we just extend that a little bit, the natural thing to make a group different is to put a little methyl group there, and that would mean this would be the chiral carbon there, and then we just fill in the H's, so that would be another one. Assume we've got 6 carbons, just to make sure. 1, 2, 3, 4, 5, 6. And then if we were again to react this under base hydrolysis and then acidify it, this group here, the acid side now would in fact be soluble, and so when we redraw this on this side, all we're going to do is redraw this exact thing, and we're just going to add an OH. So an H is going to come in here and make that an alcohol, and that's all we're drawing there for the possible product for B. So that would be 2 done. Again, this would not appear, this C double bond O, OH, H, that's methanoic acid, that would be water soluble, so we wouldn't put that there, but this long chain alcohol would not be soluble, and that would appear in the organic layer. Now, in looking at this, it seems like there's some easy things we can do. For instance, if we put the methyl group, I don't know, off here for instance, so that we had a methyl group here, and this is where the chain effectively finished. Something like that, we'd still have an optical isomer there. So let's just play around with it and see if we can do that. Okay, so all I've done is redraw that, and just got to make sure that I've done it correctly. So got 1, 2, 3, 4, 5, 6, and is this an optical isomer? Do we have 4 different groups? Yes, we do. So then, if we do this one and have that react, then obviously this is pretty same as the other one. That one's going to go, and we're going to have instead of an O, we're going to have an OH here. So when I was redrawing it for B, this whole structure here obviously would be A, but when I redraw it on the other side, the one I've surrounded in green with the OH would be B, the product of base hydrolysis followed by acid hydrolysis, but the actual ester to start with would be this whole one that's optically active. And this one really is just a case of moving that methyl group along the chain a bit, and we still have an optical isomer. So if we were to react that in the same way, obviously this group would go, and drew that a bit too quickly around there. That would go there, and we'd end up with an OH. So this is a 4th possible product, and when we redraw it on the other side for B, this would be the one we'd draw here with just an OH, so we'd include that in there, and that would be an insoluble alcohol just because of that long chain there. Okay. And finally we'd have a CH3 here, and the thing with this, it's very easy to draw the same structure and think you're drawing the same thing, so as you go through this, just make sure you are drawing different structures. And in this case, this is the first one we've come across that's got this 2 carbons going to the acid, and so that's the chiral carbon. So this is going to be soluble if we undergo hydrolysis. Sorry, I shouldn't have done that. Around there, keep on doing that. But that will go. This will become an H when we do that. So when we draw B, that's going to be the alcohol that we draw. The acid, of course, will be soluble. Okay, and that's that question answered. All right.